Hi everyone, this video will talk about return loss. So this video will cover what is return loss is negative or positive sign, why in VNA return loss S11 always shown negative value, why always focus negative 3 dB or negative 10 dB, why cutoff frequency at 0.707 volt or negative 3 dB, what we can get information from return loss, and summary. Okay, so first, what is return loss? Return loss is a measure of the effectiveness of power delivery from a transmission line to a load. Okay, an example, an antenna. Okay, so something like this. To measure a power delivered from the VNA to the antenna. Okay, so from here we can know that how much the power that have delivered to the antenna. Next, the power incident to the load is power incident, and the power reflected back to the source is P reflected. You can view from here, the power is transmit from the VNA to the antenna. So this one is the power incident, and here will be the power reflected back to the VNA. From here, we can know that how much power we have transmit and how much power have reflected back to the VNA. Okay, so the ratio of power incident over the power reflected in dB is called return loss. So return loss in dB is equal to 10 log power incident divided with power reflected. Or sometimes you will see they have like a negative sign. Return loss equal to negative 10 log power reflected divided with power incident. Okay, so actually you can see here will be like power reflected is here and the power incident is here because of the negative sign. When the negative sign is put over here, then they will opposite direction. Don't worry about this. I will show the detail of calculation in next few slides. It will always in positive value in dB. That means the return loss will be always in positive value. Because a passive device, the power incident always greater than power reflected. Okay, it's impossible your power that transmit from your VNA and the power reflected from a passive device, you will get greater than the power incident. Okay, let's say we have a 50% reflected power. So here will be the 3 dB that we will get. You just put in the 50% of the reflected power to the power reflect here. Okay, and the power in will be 100%. That means we transmit out the power 100% and reflected 50%. So if you convert it to dB, then will be 3 dB. So it's a positive value. Okay, let's say if 10% reflected power. So you can view from here, the return loss is equal to 10 log and then 100% divided with 10% of reflected power is equal to 10 dB. Is a positive value as well. You can refer to the reference here, the definition and misuse of return loss from IEEE. Then maybe you can get better understand about why return loss is always positive value. Next, return loss value is negative or positive sign. Okay, some reference shown like the return loss value is in a negative sign, but this has been corrected because of the wording loss. Loss indicate as negative. For example, power incident is 100% transmitted and 25% reflected power. So our return loss formula is return loss equal to 10 log power incident divided with power reflected. Then we just put in the 100% of power incident and 25% of power reflected. Then after calculate, then we will get 6 dB. Okay, so here will be the another equation. Okay, actually it's the same equation because you can see here is like only the inverse of the power reflect and the power incident compared with the first equation. So let us derive You just put the negative to become like negative power 1 here, and then we just inverse power incident and power reflect, then we will get actually the same equation. So both equation actually is correct. Okay, don't worry about the negative sign. Just important we understand the concept is correct. Next, I think we all familiar with reflection coefficient. Okay, so reflection coefficient, the gamma is the symbol, is equal to the voltage reflected and the voltage incident. And then here will be the magnitude and here will be the phase. Okay, so let's say if the return loss is in voltage, okay, so here will be like 20 log. Okay, I will show like why is 20 log because of voltage. Then we just derive it. So negative 20 log voltage reflected divided by voltage incident. Same as here, just different is the voltage and power. And we can see here is like 10 log voltage reflected divided by voltage incident, and then power of negative 2. Okay, we just put in the negative and 2 on top of here, then we left 10 here. Next, then we will get like 10 log bracket power incident divided by power reflected. Why we can convert it like this? Because like power is proportional with voltage power 2. So when we have like voltage power 2 here, okay, and the negative, we inverse the voltage incident and the voltage reflected, then we will get this equation. So this equation is actually is same as the first equation here. With this all equation, so you can understand like actually they are the same equation, just in different arrangement. So we can use either of these three equation, you will get the same answer. Okay, next. Let's say we have a DUT here, and then we have a power input and power output. So we can check like how to check the insertion loss or gain of the system. So how are we going to check this system is gain or loss? Let's say if power in is 1 watt and power out is 2 watt. View from here is like the power out is greater than power in, then is gain. So for the equation for gain will be gain equal to power out divided by power in. You will get like 10 log, if you convert to dB, will be like 10 log gain equal to 10 log power out divided by power in. And then 10 log power out with power in, then gain will be in dB. Then you just like 10 log 2 divided with 1. That means the power out is 2 watt and the power in is 1. Then your gain will be 3 dB. Let's check on another example. Let's say our gain we have equal to 10 log power out minus with 10 log power in. That means we just like expand it, the log, we expand it, then we can actually like normal mathematics, we can know like if your power out minus with your power in, if your power out is greater than your power in, then you will get positive value. That means from here we can know that the system is a gain because your power out is greater than power in. So you will get like 3 dB. So you are getting the same. Therefore, power out greater than power in, then is gain. Let's say is insertion loss. We can view from here, the formula is almost the same as the gain, but they have a negative here. Okay, you can see here is like power out divided by power in is the same. And for insertion gain is equal to 10 log power out divided by power in. Just the difference is the negative. This is why, because of the wording loss indicate as negative. Therefore, when we calculate insertion loss, they will always positive value. Next slide will give you an example for insertion loss. So let's say the same system, but the power in is 10 watt and the power out is 5 watt. Power out is less than power in, then is loss. Okay, so let's say when have a system, we want to calculate, let's say, loss or gain. So equal to 10 log power divided by power in. Then we just calculate it. We just put in the power out is 5 watt and the power in is 10 watt. Then we will get negative 3 dB. From here, we know it's a loss because it's a negative. Okay, but if we use insertion loss equation, they have a negative here. Then we put in the power out and power in. We will get the insertion loss is in 3 dB. When we talk about insertion loss, people will know it's a loss because it's an insertion loss. So the loss is indicate the negative. So everyone know is a negative. It's a loss for the system. Again, loss indicate as negative sign. So we no need to mention the negative here. Okay, so next. Okay, so from here, I will show you which formula we should use or easy to memorize. Both equation also can use, but for easy to remember, I will show you which one easy to remember. Okay, so this is example of measure the antenna. So we have power incident and power reflected. As we know, power reflected always lesser than power incident, therefore it's a loss. Let's say we have a system, we have power in here and power out after pass through the DUT. And here will be the antenna, same setup as this one. We have a power incident from the coaxial cable. When travel to the antenna, we have some power reflected. Okay, so our power reflected is here. And then let's say here, power out is greater than power in for here, the system, then it's a gain. So the formula, the equation we'll use is insertion gain is equal to 10 log power out over power in. For insertion loss, power out less than power in, then it's a loss. Okay, so from here, we can see that actually the concept is the same. Then the insertion loss is equal to negative 10 log power out divided with power in. From here, actually, we can see the concept is the same. Our power out, actually from here, the system, the power out is same as the power reflected. Okay, power in is the power incident. From here, we can see the concept is almost the same. So let's say the power out, actually, we assume is a power reflected. That means power in is the power incident here. So the power incident transmit from the coaxial cable to the VNA and reflected back. Okay, so this one is a power reflected. And you can view from here, the power reflected is always lesser than power incident, and the power output always lesser than power incident as well. It's a loss. Therefore, we have a negative sign here because it's insertion loss. So here will be like return loss because loss here. Then we use a negative sign here, and the power reflected is same as the power output here, and the power incident or the power input will be always at the bottom here. So if you understand about the insertion loss, then easily you can understand about the return loss. Or if you can understand the return loss, you also can understand the insertion loss. Therefore, you can always put negative sign in front of here, and the power output or power reflected divide with the power input or power incident. But you need to remember for return loss, they have a loss wording, so we can put the negative sign here, and insertion loss, they have loss wording here, so it's a negative sign here. For gain, without the loss wording, so don't put the negative sign here. They are the same equation, but without the negative sign. So you no need to bother about the equation here. You just remember the equation of the return loss here with the negative sign is same as the equation as insertion loss here. This will not confuse yourself with insertion loss and return loss with other formula as well. So here is some note. It's like loss indicate as negative sign. Insertion loss and return loss in dB always in positive value. Okay, so from this side, why in VNA return loss S11 always shown negative dB sign? Yeah, when we talk about return loss, it's always positive sign. But why in VNA is always show negative? Let's say the marker here. is negative 18.90 dB, and the y-axis here for S11 is negative sign value as well in dB. Okay, y, and you can view from here the ADS simulation. Our S11 also a negative sign, and in CST as well we also get like negative sign. Okay, so you can refer to the help file here as well for better understanding. The help file will show something like this in the Keysight VNA. So we can check like here. S11 is A divided with R1. So the S parameter. So let's say example S11 is A divided with R1. That means the A will be here. Is measure the signal into the VNA. That means signal out or reflected of the DUT. That means it's like reflected signal to port 1. Okay. That means voltage reflect is A. And R1 will be reference receiver. They are measuring the signal as leaving the analyzer source. That means R1 measure the signal out of port 1. That means it's the voltage incident. That means come out from the analyzer source. Okay, therefore, we assume voltage incident is equal to 100% and voltage reflected is 10%. Then we have like S11 equation equal to 20 log voltage reflected divided with voltage incident. Why 20 log? Because it's voltage. In VNA, the signal source is always in voltage, so we use 20 here. And without the negative, why? Because S11 is not return loss or insertion loss. Without the loss wording, we cannot use negative value here. Therefore, just place in the voltage reflected and the incident voltage, then we can get negative 20 dB. Okay, so let's say for return loss. Return loss is equal to negative, the negative sign here, because loss 20 log voltage reflected divided with voltage incident. Then we calculate it, then we get return loss is equal to 20 dB. Therefore, return loss is always positive value and S11 is negative value. That's why in your VNA, you will show negative value in the graph. So this solves like why VNA is showing the negative value in dB for S parameter. Remember that S11 is not equal to return loss. Okay, so don't confuse with these two. When we talk about return loss, is positive sign. When we talk about S11 is negative sign. So if you want to plot the graph in negative, you can define the y-axis is S11. But if you want to plot the graph is positive, you define the y-axis graph as return loss. Why always focus on negative 3 dB or negative 10 dB? We always heard antenna filter or most of the RF design, S11 must achieve below negative 10 dB. Okay, so like why is it always focused on negative 10 dB? Let's say we assume our power incident is 100%, is equal to 1 when we divide with 100. For S11 equal to negative 10 dB, we have the formula. So without the negative sign, because it's S11, and we will get like negative 10 dB equal to 10 log power reflect, power incident. Then we try to find the power reflected. Then we divide with 10. Okay. Then we get something like this. Next, we going to remove the log. So 10 power of negative 10 divided with 10. Then we get like 0.1. Then the power incident multiplied with 0.1. The power incident is 1. So we get power reflect is equal to 0.1. Okay. So the power reflected actually in percent is equal to 0.1 multiplied with 100%. We get 10%. What does this mean? This is mean that we have an incident power here from the VNA to the antenna, 100%. And when it travel to the antenna and some signal is reflected back is 10%. So where is other balance of 90%? The balance of 90% power travel to the antenna and the antenna use it for radiation. Okay, this is why always we focus on -10 because at least they have 90% balance of the power transmit to the device, or example for here, this to the antenna. This is why our S11 must be achieved below -10 dB. Next, for power divider or filter designer should be familiar with the cutoff frequency at -3 dB. Okay, like why focus on -3 dB? Like why -3 dB? We assume our power incident is 100% equal to 1. For S21 is equal to -3 dB. Example, let's say this is a filter. We have a power input and then power receive here. This is the graph. Always show the cutoff frequency at 3 dB, -3 dB. Okay, so here is 0 dB. So this one is a low pass filter. It will pass all the lower frequency and not allow the higher frequency to pass. Okay, so why always -3 dB? From here, the equation we can view here is like S21 dB equal to 10 log power received divided by power input. Okay, power received divided by power input. -3 dB equal to 10 log power received divided by power input. Then we have like 10 -3 over 10. Okay, then 10, then log power received divided by power input. Then the power received power input equal to 10 power of -3 divided by 10. And then we have a power received equal to power input equal to 0.5. Then we have the power received equal to 0.5 times the power input. Then our power received is equal to 0.5. Okay, so this is mean that our power received is equal to, in percent, is equal to 0.5 times 100%. You will get like power received is 50%. This is mean like at the cutoff frequency here, we have at least 50% of power received from the input. Okay, so always when we heard about like -3 dB is the cutoff frequency that at least 50% of the power received will be at this point. This is why always we focus on -3 dB at the cutoff frequency for band pass filter or power divider. Okay, so now you know why -3 dB. Next, why cutoff frequency at 0.707 volt or -3 dB? We already know why -3 dB, but why 0.707 voltage here in -3 dB? We know that the power received equal to 0.5 is 50% of the power received. Okay, so we also know that the power is proportional to voltage power 2. That means like 0.5 power is equal to voltage power 2. That means if voltage equal to square root 0.5, we will get 0.707. It's the same as the 0.707 here is indicate of 50% of power received. This is why the cutoff frequency always show at 0.707 volt or -3 dB. Okay, so some information from return loss. So from return loss, we can know that the lower the reflected signal indicate the more signal absorb or travel to the load. Okay. And then high return loss mean low reflected power. So high return loss is good for a system. That means the higher the return loss, the lower the reflected power. Okay. So reflection coefficient, gamma equal to voltage reflected divided by voltage incident, refraction coefficient. From refraction coefficient, we convert it to law, then we will get like return loss. So this is the return loss equation, equal to negative 10 log power reflect divided by power incident, or you can use this return loss is equal to negative 20 for refraction coefficient for voltage. Okay, so take note, gamma value is only between 0 and 1. You can view from here, always is 0 until 1. Why? Because your reflected signal won't greater than your power input. Your power input only maximum is 100% is equal to 1. So you won't be greater than 1. Therefore, the smaller refraction coefficient, that means the lower reflected power, have a good system. Yeah, because voltage reflect should not greater than voltage incident. That's why your voltage incident is 1. That's why your voltage reflected is 1 greater than 1. That means 100%. Okay, so for summary, return loss in dB always positive value, okay, because of the loss wording here. And negative 3 dB is 50% of the power. And negative 10 dB is 10% of the power. So example here is like, if let's say you have a coaxial cable and then your power input is 100% to the antenna and reflected back the S11. So S11 is equal to negative dB, means 10% power reflect. The balance of 90% travel to the antenna for radiation. If your S11 is equal to negative 20 dB, mean 1% power reflect. The balance of 99% power travel to the antenna for radiation. Therefore, the lower of the S11 negative value, the lesser the power reflected, the more balanced power can travel to the device or the antenna for radiation. And always remember, S11 dB is not equal to return loss. That's why S11 always in negative value. And return loss is always in positive value. This is in CST, so you can see here, you can view from here that is S11, and that's why they have a negative value here. Okay, so that's all guys. Thanks for watching.